Without much further ado, Raul and Lane.
All right, here we go.
Screen 2. Okay, so you want to go to our PowerPoint. CSSA one. Oh, is it this one?
Yes. This
That's the first. That's the one. Okay.
All right, are we good? Can you see the screen well? All right. Good morning, everybody. First of all, I would like to thank the Cactus and Subsp Society of America for the invitation, to give this presentation. It's a project that we've been laying myself. We have been the co-PI for the last 2 years and trying to, well, do some reintroduction, some restoration on the cactus, the Echinocereus arizonicus, subsp arizonicus. And this is a project that we've been doing very close to Phoenix. So for us was an ideal species, to try to figure out a methodology, for augmenting populations in some of the endangered species. For us, the localities where they grow are an hour and a half, away. So we can do sometimes field day trips, or usually we spend a couple of days over there, 2 or 3 days, doing the work. So the project, like I say, is we had this Echinocereus arizonicus, or called the Arizona hedgehog cactus. The subspecies arizonicus is one of 3 subspecies that were known. There's Arizonicus matude, that grows more on the southern part in Mexico, in Chihuahua, and the Arizonicus subspecies nigrihoridis pinus, that grows more like southeastern Arizona. So similar subspecies, a little bit tricky to tell them apart. There are variation, in sizes and form and shape of the spines. So with a lot of practice, and once that you see a couple hundred, you get the gist of how to see it. So the Arizonicus, subspecies Arizonicus, it's a relatively large cactus. Cespitous, it produces a lot of stems. You can find plants with 10, 20, 40, and the largest plants that we have found, it had 118 stems. That's the largest that we see. So they are very big in size, and which makes them ideal, for as far as endangered species goes. Most of the endangered species are very tiny, and you are crawling, down on your floor trying to find them. That is not the case with the Arizona hedgehog. You can see them across a wash. If you pay attention, you can start seeing them. So that's also helpful. The species are very showy with these orange flowers. They are pollinated by hummingbird, but as well as some of the native bees. And the habitat that they prefer is always these rocky rhyolite fields, boulder fields. So and growing among chaparral, oak forests, and pinyon pine and oak forests. But yeah, the habitat that they prefer is very rocky and a little bit difficult to walk, and hike through. Most of the populations are at the 4,000 to 4,500 feet of elevation, but there are a couple of these young populations, that go to 5,700 feet of elevation. So it has been a little bit of discussion, how many plants are still out there. Some of the collaborators, they're Fish and Wildlife have determined this range, but just by going by the range, it's a little bit misleading because there are many sites that the current range that has been determined, they don't grow. They grow in some sites that is still need to be surveyed, just to find the presence. But all the blue dots that you see, those are confirmed individuals that have been seen and mapped, with a GPS, and you get points, and this all goes into a database. So we knew of about 6,000 specimens, but there has been impact, for some of the recent fires, and I'll explain that a little bit. So the area that occupies right now, all those known points, is about 25 kilometers long by about 10 kilometers. So, which is still, and then you can see those two disjunct small populations, one on top of the mountains. But in between, there are these blank spaces, that still need to be surveyed. As I mentioned, here in this map, you can see the difference. The large polygon, the green polygon, is the distribution of the subspecies Nigri spinus and the subspecies Matude in Sonora and Chihuahua, Mexico. But you can see by comparison, the arizonicus has a really small population, the range. So the conservation status, in 1979, it was included on the Endangered Species Act. So that's 40 some years ago. But as far as the IUCN, about 15 years ago, there was an assessment for all the cactus family, and the IUCN assessments are at the global level. They is done also at the species level. So if there are subspecies or varieties, they are all lumped together, into a large polygon. And which that's one of the reasons why the IUCN is still listed as least concern, which doesn't help, with the conservation of these arizonicus. The threats, there are multiple. Mostly have to do, the habitat degradation. The hedgehog grows right in the middle of what is called here in Arizona as the copper corridor. Is that area between Superior, Globe, and some of these mountains. So there are 20 some mines, is still in operation to this day. So all of these 20 mines, they need electricity. So there are a lot of power lines going from one mine to the other. And one thing that they do is that they have to maintain all those power lines. And when they talk about maintenance, what they do is they go and clear out all the shrubs and trees, under the power lines. That's to protect that in case of fire, that they might burn and then damage the power lines and stop the energy to the lines. Road construction is another one. There have been several projects for widening Highway 60, that is the highway that cuts right through the range. And on each one of these projects, hundreds of plants have been transplanted, dug up from the footprint of the project and move, a few couple 100 feet away, and then they have pretty much left to themselves, and hopefully nature will help them to get established. And because of that, a large number of these plants have been lost. Grazing, all the areas in Tonto National Forest, there is grazing. So the cows is also damaged. But the main problem that we have seen recently has been the fire. There have been a couple of, at least 3 fires, that have impacted, the population of this hedgehog. Plant removal, that was the main reason why in 1979 they were listed and included in the Endangered Species Act. And so and back at that time, the people that proposed the species to the Endangered Species Act decided that the legal removal of these plants, was a big problem, so it required to be included on the list. And this is something that we haven't seen recently. We've spent a lot of time, and I want to think, that being inside the national forest, is now getting a little bit of protection. Climate change, and the impact of climate change. Well, the fires is definitely one of the one of the factors, that we're gonna see. And here is just to give you an idea of the fire. In 2021, in summer 2021, we had the Telegraph fire, which came right through the range. Here is the black outline is the potential range, for the Arizona hedgehog cactus. And then you can see the red shaded area. That was the area burned by the Telegraph fire. And the red line in here is Highway 60. So you can see that about 50%, of the estimated range, was impacted by the fire. So we knew of about 1,600 plants, in the southern part, and a lot of them, got burned. And you can see this is what the fire have done to some of even the large plants, depending on the intensity of the fire, and sometimes the plants that are growing on top of boulders, they escape to some of the fire. And even some of them, we have noticed that they are able to produce new growth, that's after the fire. If there's some a green tissue, they will immediately start growing these new arms. So there probably some type of adaptation, to the fire. So, but we don't know for sure. There have been a couple of recovery plans written for the Arizona hedgehog, but they haven't been approved. So there's a proposal to write a new one that hopefully will get approved. So all the problematic of these hedgehogs has been well documented, and also recommendations, included propagating a mass propagation of this. So that was one of the reasons, why we want to follow one of those recommendations, to try to reintroduce some plants, to augment the populations. So we want to do that with our projects. Before that, we have been involved with 2 projects. There have been other institutions also involved. Boyce Thompson, they also were participating on salvaging, some of the salvaging. They even had a display of the Arizona, very nice displays, with interpretive signage about the Arizona hedgehog cactus and the reasons why they are threatened, and some of the efforts, that they were involved with. But we started our involvement back in 2018, where ADOT, the Department of Transportation, they needed to replace this Pinto Creek Bridge. It's an old metal bridge, that was over 50 years old, and it receives a lot of traffic, especially heavy traffic from the trucks. So there were some 57 plants growing right on the footprint of the old bridge that they were going to be impacted for construction of the new bridge. And because they haven't found somebody who can do and work on the slopes and and even some of the cliffs, they had considered those plants that they were going to be losses. That they didn't have anybody to go and do the salvaging. And some of us talked to some of the fish and wildlife people when they told us that there was that problem, that didn't have anybody to do that. We volunteered to do it, and some of us here at the garden had experience rappelling and that, and we decided, well, yeah, maybe we can do that. So we submitted a proposal, and they accepted it, and then we went put together a crew here from DBG, and this is the way we salvage it. We went in order to, there some of these large plants, if you try to dig them out, we do nothing, they will just fall apart. So we will just wrap it on this Saran wrap, and then and wrap them in burlaps, and that way we were able to keep the plants intact. Some of these large, and then we had just to take them uphill. So here's a view of some of the plants that were on the cliffs. A lot of them were easy climbable, but it was always better to be safe. So we used ropes and harnesses. Just we didn't want anybody falling down the cliffs. But you can see some of them were right at the edge. Here's Steve Blackwell from DBG. So this is some of the gear that we use, just climbing gear. We had to improvise, what to do to carry the plants. So we had to come up with some ingenious ways. And this is during that project, there were small plants and some of them were larger. So we used different techniques. We went to Home Depot and bought these cement tubs, to mix cement. And they work great, to make this kind of a sleds that we could just pull over the along the slopes. And one night, I remember the night before we went to this trip, I drove by the neighborhood CVS drugstore, and they had a big stack of these gray crates. And I thought, oh, that's my work. So I borrow a couple, and thinking I'll bring it back later. So we used it, we improvised like a backpack, and we were able to hike out. Okay, here it is, just a few straps, and it has a single plant, a large plant with like 40 stems. So that worked. And yeah, here's more views of how we did this. So yeah, it was a lot of effort, and of course, this was July. Yeah, we were working on 100 degrees weather. So because we had planned this, but they always change the dates that you're supposed to do things. So we had to go there in the middle of the summer. So here's Steve, walking, also one of those big plants. And this is where we are at the slope. Like I say, most of it was just low angle, maybe 30, 40, or even easier climbs. But, you're carrying backpacks, you're carrying your gear, you're carrying your water. So it was always safer to have a rope to. So one of the things that they want us to do was that they want us to dig out the plants and transplant it just the way that they have been doing it. But when we ask about the survival of the previous plants, we saw that a lot of them had died. We decided, no, we're not going to do that. We want to take them back to DBG, pot them up, and get them to rehab and grow roots. And then once that they finish, the bridge is finished, we're going to bring them back and do the transplants. So that's what we did. We had it at DBG. The bridge lasted 2 years, the construction. And then we were able to, the plants bloom for 1 year at the garden. We were able to do cross-pollination and get a lot of seeds for to store in our seed bank. And then when they finished the bridge, this is what we had to work with, this kind of land, it was just total demolition, there was no plants. So we reintroduced some of the plants in some of the areas, 60 plants in we had to find just a little bit of vegetation to put them under, but we managed to reintroduce 60 plants, and we did monitoring, and most of them are surviving so far. So this was our first experience doing reintroducing these plants into the wild. One of the things that we want to make sure it was that they want to get established. So we decided that from day one, we're going to be doing some kind of maintenance, So we decided to water our plants because we saw that the weather, the high temperatures here, even at the mountains, it was going to be a factor, that it will impact the survival of the plants. So we decided to come and water. So we watered at planting, and then we did an additional watering right before the summer. And for that, again, we had to improvise. So we found some of those shower, camping showers, that you use just these bags that hold 2 gallons of water, but they already have a head that, that was pretty easy to work with. So that was the first thing that we did. And then we monitored the plants, and we found that, the ones that they were in the ground the first year, they bloom, and some of them even set fruits. So we thought that, so there was hope for that. So that was our first round. We had to monitor, we have seen since then, we are still following this first 60 plants. Some of them died, but we still have like 90% survival on this initial project. But that's what it gave us. Well, it is possible, probably, just to reintroduce more plants. So now Lane is going to talk to you about our second project.
Thanks, Raul. So as Raul just mentioned, the first project was a salvage reintroduction, and we wanted to go a little farther than that with our second project from 2021 to 2023 and actually augment the population of the Arizona hedgehog cactus on the ground. So actually be out there planting new individuals. So we propose under Section 6 of the Endangered Species Act to go out on the forest, locate large wild plants, and harvest a total of 300 stems from numerous large wild plants, bring them back to the DBG, where we could get them to callus over and root under controlled conditions in a shade house, where they would be maintained and watered for 10 months, and then transplant them at population augmentation sites or restoration sites in the field on the forest, and then post-transplant water and monitor them for 8 months. So this may seem shocking to some of you, and I just want to stress that this kind of project where we go out and we're harvesting endangered species material is not the norm. We had to not only get permission from the Section 6 committee through the ESA, but also get Fish and Wildlife Service permission to do this harvesting and transplanting. So this is actually the permit that we worked under, where we were able to go out on the forest with Fish and Wildlife permission and do the different parts of our project. So why would we want to do asexual propagation from cuttings rather than using seed? Well, the main answer is that the Arizona hedgehog cactus is a relatively slow grower among the Cactaceae. So you can see it's about 1 centimeter tall on the left top at 1 year and 1 month. The ones below that are actually 1 week and 1 month old, but they're just out of scale. And then the middle panel shows an individual grown out to 3 years and 7 months, which is only 4 centimeters tall. Whereas with the cuttings we made, we could get a fully rooted 15 centimeter tall individual at 3 months. And basically 15 centimeters is the hypothesized size that we think an Arizona hedgehog cactus needs to have attained to be able to withstand field conditions at transplant. So anything smaller is likely not going to make it. And another reason to take these mature cuttings is that once they're rooted, they can flower and set fruit immediately, year by year, and be reproductively mature and capable. So that was why we chose the asexual propagation method. And this is a basic calendar of the 2 years of our project. Just to run through it really quickly, I'll actually go through each step in more detail after this slide, but we needed to scout for plants to collect on the forest in late 2021, get our collecting permit, of course, and then collect the plants in early 2022, bring them back to the DBG to be potted, and rooting and maintenance started as soon as they were potted. We built a shade house in May to house them. And then in the second year, in late 2022, we needed to find new microhabitats to plant the transplants in while rooting and maintenance continued. And then in early 2023, we would carry out the transplant into the ground on the forest at the 3 restoration and population augmentation sites. And we would water the plants at planting and at monitoring. So we monitored and watered in June. We monitored again in September, but didn't actually need to water because the monsoon rains had just hit and the ground was soaked. So yeah, we set this up to best catch the rains, especially the winter rains at planting, to time the planting so that it happened at the same time as those winter rains. So stem harvest, as I mentioned, involved 2 phases. First, we had to scout for the plants, and then we had to collect them. This is just a Gaia track of all the places we drove and hiked to find the plants that we were eventually going to collect from and then go collect them. We have photo points at a lot of these places. So we had a pretty elaborate process and set of requirements for the harvesting, and this was to keep the parent plant and the cuttings safe. So we searched for large wild plants that had more than 20 stems, and we made sure that they were healthy with little to no damage, no disease. And we only took 10% or less of the stems of a given plant. So if we had a 25 stemmed plant, we would take 2 stems or less. And we eventually harvested from 4 subpopulations of the 5 that we scouted, which I'll show you in just a minute. But I wanted to highlight the process that we did at harvest. We first cleaned the cutting knife with alcohol or bleach, and then made the cut to get the harvested stem. And then we treated both sides of the collection wound with agricultural sulfur to make sure that no disease or any other pathogen could get into the parent plant or the cutting. And this was the kit that we carried with us that had the bleach, the paintbrush, the sulfur, all the things we use to take care of these plants at harvest. So this shows the 5 subpopulations that we scouted. Of these 5, we harvested from 4 of them. Only Devil's Canyon wasn't harvested from because we didn't find enough plants at that site. And on the left, you can see the basic ratio in light green. There's number of plants collected from, and then in darker green, the total stems, number of stems collected. So we basically, in total, got 300 stems from about 120 plants total. And just to give you a sense of what some of these sites looked like that we scouted and collected from, these 2 we actually did both. Queen Creek Canyon and Top of the World, you can see Raul mentioned that Arizona hedgehog cactus tends to prefer rocky areas with boulder fields and rocky substrate, as well as nurse plants. So you can see both of these sites are perfect for both of those things. We didn't collect from Devil's Canyon Road, but we did collect from North Cerro Road. Again, you can see the boulder fields. But I included the Devil's Canyon Road shot just to show you guys the fire line of the telegraph fire from 2021, where it came through at this site. You can see on the right, the well-vegetated kind of lush landscape, and then on the left, the denuded boulders with no vegetation after the fire. And Pinto Creek was another one of our scouting and collecting sites. It had pretty steep topography. This is actually the slope across from where we collected. So the slope where we did collect was a little less steep than this, but we still had to use climbing equipment at times to get around. The old Highway 60 shot is that, of one of the sites we planted at, so I'll get into that. So once we had collected the stems, we brought them back to the Desert Botanical Garden for a 2 to 3 week callousing period, so they would heal over completely and be able to root. And then we had these 2 wonderful volunteers, Tia Daneman on the left and Wendy Barrett on the right, who potted up our cuttings from February to March of 2022. And then, of course, rooting began immediately after potting, and we assessed roots at 3 months. You can see a couple of the plants that we dug out and assessed had a lot of roots after 3 months, and then rooting continued basically through the period of transplant. So in between, we had bought these rodent-proof benches to house the cuttings on, and we also built a shade house over those benches to protect these rooting stems from the valley heat, because as you know, Phoenix area can get very, very hot in the summer. We also watered these guys only once a month to help harden them off, make them ready for field transplant, and make sure none of them rotted, since they were basically precious cargo. So we were given funding to construct the shade house from the Tucson Cactus and Succulent Society. So we wanted to call them out here and thank them for that. And at about 10 months after collection, we went back and performed a post-collecting wound check on 20 or 30 of the the parent plants just to make sure the wounds had healed properly. So on the bottom left, you can see one of the parent plants that has been collected from, just looking green and vibrant. You can't see any of the wounds from just standing viewpoint, but we also have zoomed in close-ups of the collecting wounds. Here's one, here's 4 stems that were collected. So you can see that the sulfur did its job. They did not get any infection of any kind. They completely dried out, and the rest of the plant was not affected by the collection wound. So then for actual transplant, we had 2 phases. One was microhabitat scouting in late 2022, which I'll talk about a little more in a second. And then of course, transplanting the 300 stems in early 2023. So to select these sites, we chose 3 sites that would allow us to make a comparison. So Top of the World had more intact habitat than the other 2 sites, less disturbance, no grazing. And then Pinto Creek was right next to the disturbance from the bridge construction. And Old Highway 60 actually burned in the 2021 telegraph fire and was coming back afterward by the time we did the transplants there. So we wanted to compare an intact site with a post-burn site with a construction impacted site. So that was how we chose our transplant sites. And for microhabitat scouting, we went out to each site and looked for microsites within chaparral and pinyon juniper vegetation with nurse plants, some open sites, but mainly in boulder outcrops, and making sure that each microsite had a depth of at least 10 inches of soil to accommodate the roots of the transplants. So at each microsite, we flagged these points, and we took a GPS point using a bad elf, which has accuracy to about 20 centimeters on a good day, but only like 50 to 70 centimeters on a bad day. So it's very, very accurate even on a bad day, as you can tell. That basically allowed us to be able to find each and every microsite point, even if they were close together, with accuracy. So transplanting, when it comes to transplanting, it took a lot of people to do this project. You can see the line of cars at the top. We've got Forest Service, we've got DBG, we had some US Fish and Wildlife come out with us. And basically we took the potted plants with us into the field and staged them, and then depotted them and cleaned the root ball of potting soil and bagged each rooted stem in a paper lunch sack, and then bagged all the paper lunch sacks in a larger duffel, so that we could then carry all of our gear, all of our plants, and all of our water for the transplanting effort from wherever we had parked out to the field site. So for transplanting, it was a simple process. We basically excavated a hole to the depth that we needed for the roots with a hand pick, and then set the planting in the hole and from the soil around it, and then watered afterward. We also made like a little trough around each plant to catch the water, so that the roots would most efficiently get water at transplant. And this was to avoid transplant shock as much as possible and give the plants a better chance of survival. So each transplant team was generally one person digging the hole, planting the plant, and taking the first measurements of the plant, one person taking data, and then a third person coming after to water. And this was our Pinto Creek site, which is pretty steep. You can see us on the steep slope here. So at each site, there were just a few cacti that were found when they were unbagged to have too few or no roots, or when they were unpotted to have too few or no roots. So we planted almost 100 at each site, but we took the ones with too few roots back to the DBG for rooting, and we brought them back once they were rooted and planted them at each site in November of 2023. So that's how we got our entire 300 planted. And this is basically just a fun video that Raul's GoPro made of the planting process that I'm going to show you guys. So you can see that we actually got snow after our first day of planting. So that definitely coincided with the winter precipitation. We actually had to monitor a little later so that we could walk safely and not be in the snow, the deeper snow. So for results from the transplant, this just shows the distribution of the points, the transplant points on the landscape. This is our post-burn site at Old Highway 60. We clustered the plantings to mimic the way we observed the Arizona hedgehog cactus in the wild. And each site, each planting area, both at this site and at the other two sites, was roughly 1 hectare or 2.3 acres in size. So here's our top of the world site. This is more like a transect that runs along the rhyolite out to this huge bench. This was our most intact site with more intact habitat, more vegetation cover like pinyon and juniper, and there were actually numerous wild plants along this transect. So we were augmenting the population here, which, to actually go back for a sec, at the post-burn site, the Arizona hedgehog cacti that had existed here had actually mostly burned, and the ones that had survived were doing poorly. So when we did our transplant at this site, we were actually restoring Arizona hedgehog cactus to this site, whereas at the top of the world site, we were just augmenting the existing population. And finally, here's our Pinto Creek Bridge site. You can see the topography is a bit steeper. The site near bridge construction, there were a few native wild Arizona hedgehog cactus here, so we were basically just augmenting this population as well. And the site here, unlike the other two sites, is grazed. So the cows came back as soon as the bridge was reopened after construction and destruction. So we continued after transplant with monitoring. We went out in June and watered and monitored, and the variables we took were height, diameter, number of ribs, number of flowers, and number of fruits was especially important because we wanted to get a sense of the phenology of the species, how it was doing, whether our transplants were actually being actively reproductive after the transplant. And then we also monitored condition, any damages to the plant, and we took a record of any nurse plants that we had planted them under, so we had that data. So Raul is going to take it from here and give you the rest of the preliminary results from the project.
Yeah, so as you can see, getting all those plants out in the field, you know, it took quite a bit of planning and effort, and especially, you know, Lane was pretty good at the logistics. You know, we had to coordinate a lot of people, you know, make sure that they were available and they could come and help us on all these parts of this project. So right now it has been 2 full years, you know, where we have done the monitoring. So we have some, except preliminary results. Here's one of the plants on the right side is one of our out plants. This was a large plant, you know, it had all these stems, but 2 years after being in the ground, you can see the amount of fruits that have been produced. And I have to say, you can see this metal tag. Each plant we put a metal tag, and the way that we had, each tag had a number, and the number on each tag, it would allow us to keep track and be able to tell where it came from. So we had then each one of the subpopulations that we collected from, we have given a number, and then each one of the mother plants that we collected was assigned a consecutive number. We had the plant number 1, 2, 3, 4, 5, and that number goes on the tag. And then some plants, we collected one stem, so that stem will be 6938.1 and 0.1 for that stem 1. But if we have multiple stems, it will be 0.1, 0.2, 2, 3, 4, you know, or whatever many we need. That way, when we read the tag, we can tell exactly where it came from, and which plant. So the plant number is still out there. So yeah, so that is a way that we were keeping, making sure that we have some control on the plants. So yeah, like I mentioned, Elaine mentioned, what are the things that we want to monitor and look at, and so to have an idea of if the plants are getting established or not. We are still, we know that it's only 2 years for a cactus. We're hoping that maybe by the 5th year we're going to have a better idea of the plants are establishing or not. But in the meantime, we're going to continue monitoring. One of the things that we were monitoring for that was important for us, it was the condition. We had these categories: excellent, good, fair, poor, or dead. So and we had excellent. It was a plant that it didn't have any damage, associated with the transplant. Good, plant that it might have some damage, but it was only like probably 10%, 10 to 15%. Fair, it was a plant that might show some damage, maybe in like 25%, we say for that. And the damage could be sometimes, that the rodents will come and chew on the stems, or we had cases where the plants were exposed and there was damage by sun scorch, and you can see, what proportion of the plant what has been impacted. And anything that had more than 50% damage, we were considered as poor. And that, were plants where there were just no green tissue at all. But you can see that for all the three sites, the excellent and the good conditions was what we could see more. The very fewer plants, in the fair and poor condition. This is for the first year that we saw. Then we look at damage. What is this actually impacting our plants? So we saw the herbivory. Mostly we had herbivory, sun scorch, plants uprooted. We found some plants that were uprooted, and some of them were trampled. In the case of the one in the areas with cattle, they had been trampled by some of the cows in the area. We noticed a little bit of frost damage in the apex of some of the plants, but it wasn't bad enough, that will destroy the plant. They usually will grow out of it. But the herbivory and sun scorch were the main causes of damage. Herbivory, like I mentioned, we found that pack rat nests, the Neotoma albigula, very close in some of the populations. So even though we never saw the pack rats in action, we expect that it was that because of the droppings next to the plants, as well as the damage, the size of the damage, the size of the bites. You can tell that it was a larger. But we also found this beetle, the Monilemas beetle. They will actually eat in the stem. They take little bites of the epidermis. Not as bad as the Neotoma, but still, it will contribute. The plant will start dehydrating, losing water from the wounds, and the wound will get bigger. But like these two are good examples of how the pack rats, they completely ate the plants, and these plants, we found them later on, they were completely dead. So we wanted to mention, that the stems were already mature enough, that they were reproductive, and so it was important, to find out how many of those plants will produce flowers, they will bloom and potentially produce fruits. So we did one of the monitoring was right at the blooming season, and then we came back during the the fruiting season also, just a month and a half later, just to count how many fruits were produced. But in all sites, this one we have for the 2 years, the blue for 2023 and 2024, and orange. But you can see that for one of these sites, Highway 60, we had about 40 plants, already producing flowers, and Pinto Creek, more than 50 plants had flowers already. And this is a number in Pinto Creek, that we counted more than 200 plants already in that population. And so that was 23, and for 2024 we saw again, the more or less the same pattern, but so the plants are producing flowers. And what about the fruits? Yeah, well, some of them are also, we had a good amount of fruit set, and about it varies, from 15 to 20 plants setting fruit. And last year, we had really the conditions and temperature were a little bit harsher than the previous year. So all highway, we had very little fruit production. So that's one of the changes that we're seeing. But as far as the other localities, our site, top of the world, that it was the more intact, almost 60 fruits were produced by about 30 plants. So there is some fruit set. And if we think that each one of the fruits, have about 300 to 400 seeds, that's giving us an idea of how many seeds are being uh, are being produced, and hopefully incorporated to the ecosystem. All right, so where are we at now? Here are the survival rates from year one, 98%. Right now for this year, we have 86. And for our second locality, 96 and 90%. So yeah, having 86%, to 90% is still a very good percentage. And you can see some of the damage on the plants. This is one that it was dehydrated. And this is one of the ones that got trampled by the cows. Our collaborators from Tonto National Forest were very happy to see the Arizona hedgehog, trampled by cows, because there was always this question: is the cows impacting the cactus population or not? And they didn't have any evidence. So this is one evidence that they were happy to have. So you're probably wondering, well, that looks like a very good percentage of survival. And I had to say, because these plants where they are growing, as far as endangered cactus, is in a really good location. The precipitation during the period of our the 2 years of the planting, it got 32 inches of precipitation for the whole period. It's not a year; it's for the whole period of the plant. And the temperatures, they were below 90 degrees. We didn't have any of the high temperatures that we have here in the valley. So I think that contributed to the success of, or the preliminary success of these reintroductions. Right in the middle of the summer in 2023, there was a second fire that came. This is the Carlota fire. It burned about 380 acres, and these are our plantings, and we were scared, and worried, because they got very close to our planting. If they didn't control it, they would end up with our two populations. And we helped the people from Tonto National Forest and to do an assessment of the fire, and we found that of all the known plants in here, there were like over 300, almost 400 plants. 224 of them were completely damaged, and about 50% of them were 48% were dead. So yeah, so it's amazing what we can do. So we're continue monitoring. We have seen that some of the in a couple of plants we saw a little bit of like something that looks like this bacterial, similar to like Erwinia in some other cacti. and we just gotta keep monitoring, because this can potentially spread out to another. Since then, we took out those stems, that were infected, trying to keep it. We're continue monitoring, and we are mapping, any new plants that we found in other areas, and as well as seedlings, the recruitment, what's happening, in the areas. Growth rate is something that we're really interested in knowing of the plants. This has been one of the mysteries, like how fast the cactus grow, how long does it take to get a mature size. So we have been looking at, we use this simple technique that you paint the apex, all the new spines. Eventually, as they produce new areoles, the paint moves to the side. And then you can come and measure and count the number of areoles, that are produced. So because we're doing these seasonal monitorings in a year, we have been able, what we notice is the plants are growing, but there's also fluctuation, depending on the temperature and the content of water of the plants. So that's why you see these are individual plants. But in general, we have seen growth anywhere from 2 to 6 centimeters on that 2 years period. All right, so just quickly before we run out of time, what have we learned? We were considered, based on these preliminary results, that this technique, definitely, provided that you get all the permits approved, it could be an efficient method to get cactus at a size, large enough that they can support the shock of transplant. And in a short period of time, we think that it is about a year that you can get those plants, compared to 8 to 10 years by germinating. We think that the plants so far, that what we've seen, the best survival is anything that was taller than 15 centimeters. Some of we planted intentionally, some less than 10 centimeters, and those are some of the ones that we lost. I guess, probably they didn't have enough resources, to withstand the transplant. Watering is really, really important. So we are surprised that for our side, we haven't been able to, or there was no need of going, like we were expecting that we will have to water like every 3 months, like at least quarterly, but there was no need for any of that. It was just one watering before the summer and the planting one. So far that's been good. We think that this method can be used for other species, with the same type of cesspitoid habit, other hedgehogs. There's a number of hedgehogs that are also listed as endangered, or we think, now these days, there's a lot of in the news about copiapoas, that potentially that can be another method that could be used in copiapoa and other genera that have the same type of habit. So definitely we think that putting plants out there, trying to augment the population, it should be one more of the strategies, not only for the Arizona hedgehog cactus, but for others. We always talk about how there are different things, we need more surveys, the plants need to be propagated, and maybe even put in the horticulture, to do more ex situ conservation. But I think that we should start considering, start augmenting some of these populations. And we think that doing it before the numbers are, how many plants, how many cactus we know that there are only less than 100 plants, or that there are 20, 50 plants. So I think that we shouldn't wait that long. Maybe when they are in the 1,000, it should be the time where we can try to attempt these augmenting these populations. There is still more work to do. We're going to be doing a reassessment for the IUCN, but at the subspecies level, we're going to continue monitoring. One thing that we would like to do is do a seed collection, for long-term storage. We think that if we can harvest 25 fruits and tens of population, we will end up with a roughly 75,000 seeds. That would be a good number. Sexual propagation is another one that definitely needs to be continued, even though it's slow. So I want to just give some acknowledgement to the partners, that we had during this project, the folks at Fish and Wildlife, Tonto National Forest, Desert Botanical Garden, staff and volunteers, and all the funding, the funding that we received. One of the things that we have learned with this project is that getting funding for single species conservation is hard. There's always funding for this ecosystem conservation. So it is difficult, but we had to try. We did receive funding from, like we mentioned, from Fish and Wildlife, Section 6. Some of the cactus societies, help us, Central Arizona and Phoenix, do some cactus succulents, also help us, and Desert Botanicals. And this project, there was a lot of people involved, and people from Desert Botanical Garden volunteers and our partners on the different agencies. And I think to all of them, I really want to give them a big thank you.
Thank you, Raul and Lane. That was excellent. Excellent.